everyone. I'm Swarna Latha, working as an assistant professor in the Department of Electronics and Communication Engineering. Today, we are going to discuss the expectation of a random variable. The contents we are going to see in this presentation are: first, we see what is expectation. After that, we see the formulas for expectation of a continuous random variable and the expectation of a discrete random variable. After seeing the formulas for expectation of continuous and discrete random variable, next we'll go for conditional expectation. Again, in the conditional expectation, we'll see the formulae for both continuous and discrete random variables. So first, you'll see the definition of expectation. So what is expectation? Expectation is a name given to the process of averaging when a random variable is involved. It means, for example, you're having a variable x, and the variable x consists of the values like 1, 2, 3, 4, and you want to calculate the average of this value. Then how do you calculate? The sum of all the values by total number of elements. How many elements you are having here? 4 elements. So this gives the average or the mean of this variable x. Then what is the value you are going to obtain here? 3 plus 6. So 10 by 4. That is nothing but 2.5. So this is the average of the random variable x. Next, what is expectation? It is also calculating the average, but the difference here, the average of this variable x and the random variable is, in the random variable the values are unknown. There is a difference between variable and random variable. So when you are calculating the average or the mean of the random variables, then it is called as expectation. So the expectation of any random variable x can be represented by u of x, and u of x can be represented by x bar. So this is the usual notation to represent the expectation of a random variable x. And you can call u of x in different ways, like it is called as the mathematical expectation of x, or else it is called as the expected value of x, or else you'll call it as mean of x, or it is called as statistical average of x. So these are the different names to given for the expectation of a random variable x. So simply expectation is nothing but calculating, or it is a process of averaging if a random variable has been involved. Calculating the average of a random variable is called as the expectation. So this is the definition of expectation. And coming to that, I am taking a variable x first of all. It consists of number of p values, nothing but x1, x2 and so on up to xp. And these variables are occurring at the frequencies of n1, n2 and so on, np. Then what is a average weight? So it is called as weighted average. So why it is called as weighted average? Because the values x1, x2 and so on, xn are multiplied by their weights. So it is called as what? Weighted average. Then what is the average or a weighted average of this variable x is equals to n1 into x1 plus n2 into x2 plus and so on, n into p xp by total number of values. How many are having totally your variables? N p variables. So n1 plus n2 plus and so on, np. Then if you simplify, how can I get here? Sigma I. Here what is my equals to? 1 to p. Here the my I is I equals to 1 to p. So I equals to 1 to p, ni by n into what you have here, xi. So this is what it is a average or weighted average of a random variable x, which consists of p values with frequencies of n1, n2 and so on, np. Now the same thing I am applying for random variable. So when you go for random variable, this ni by n is called as probability. So when you go for When you go for random variable, the term ni by n is called as what? Probability. Because we have seen the definition of probability and is based on the probability definition based on relative frequency approach. So this is the number of times the event has been occurred by total number of times the event has been happened. So this is a probability definition based on classical frequency. So when you involve with a random variable, then you can replace this term ni by n by px. Here, what is px of x represents? It represents the probability at the random variable x takes xi value. So it is called as what? Px of xi. So the probability at the random variable x takes xi value, a particular value of xi. Then, so this is called as the mean or the expected value of random variable x. So it can be represented by u of x. It can be represented by u of x. And what type of random variable here? Here my x is having the elements like x1, x2 and so on, xp or xn up to n number of elements if you say. Then these are countable and finite and these are discrete nature. Therefore, the type of random variable here we are taken is discrete random variable. So the discrete random variable, you can calculate the expectation of the random variable, discrete random variable x as u of x is equals to sigma I. Here I may be from 1 to infinity or 1 to n or minus infinity. So here px of xi. So what is px of xi represents? The probability that the random variable x takes xi value into what? Xi. So this is a expectation formula, or it is a formula to calculate the mean or the statistical average of a discrete random variable x. Now let us see the expectation of a discrete random variable, how to calculate by seeing an example here. What is example here? If x is outcome when we roll a fair dice, find the expectation of x. So what is my random variable here? It is outcome when we roll a fair dice. So when we roll a fair dice, what are the outcomes you are going to get? So 1, 2, 3, 4, 5, 6. So these are the outcomes you are going to obtain when we roll a fair dice. What we have to calculate? You have to calculate the expectation of this random variable x. And what type of random variable here x is? These elements are countable. How many elements? Consist of 6 number of elements. These elements are countable and finite values, and these values are discrete in nature. Therefore, this is called as a discrete random variable. If the elements in the random variable are finite and countable, it is called as what? Discrete random variable. Already we have seen in the classification of random variables. Now we have to calculate the average or the expectation of the random variable x. So what is u of x for a random variable x? If it is a discrete random variable, sigma I xi into p of x equals to xi. So this is a formula. Or else you can write it as sigma xi px of xi into xi. In any manner you can write on the formula. Now what I do is I will draw a table. So I am taking the random variable xi values. What are the xi values here? It may be 1, it may be 2 or it may be 3, because when you roll a die the outcomes may be 1, 2, 3, 4, 5 or 6. These are the elements of the random variable, and the second row represents the corresponding probabilities. So p of x equals to xi. So what is the probability that the random variable x takes is equals to 1? What does it mean? What is the probability that getting a number 1 when I roll a die? So what is the probability formula? Probability of any event. You can define as what? Number of favorable outcomes by total number of outcomes. By total number of outcomes. So this is a formula to calculate the probability of any event. This is a classical definition of the probability. Now, what I have to calculate here? Probability that getting a number 1 on the die. Total how many elements are here? 6 possibilities are there. Out of that, my favorable outcome is only 1. Then what is the probability that getting 1 when any early fair dice, it is nothing but 1 by 6. And similarly, getting a number 2 when you roll a die, it is also 1 by 6. All are having the equal probability. And similarly for 3 and 4, getting a number 5 in the die and getting a number 6 on the die, these are the corresponding probabilities. Let us calculate the average or the expectation of this random variable x. Now what I will do here, I have to multiply this xi with probability. Then what do you get here? 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1 by 6 plus 4 into 1 by 6 plus 5 into 1 by 6 plus 6 into 1 by 6. So if you take 1 by 6 common, you are getting 1 plus 2 plus 3 plus 4 plus 5 plus 6. And the value here it is. So you will get that this value is 11, 15, 18, 21 by 6. So it's nothing but 3.5. Therefore, what is the expectation or the statistical average of random variable x? What is my random variable x here? It is outcome of a fair die. It is outcome of a fair die. What is average value got? 3.5. So like that, for any discrete random variable, you can calculate the expected value or the average value. And coming to the expectation of a continuous random variable. Now, if I define x is a continuous random variable, then how can I find out the expectation of the continuous random variable? What is the formula? U of x. The expectation of x can be represented by x bar also is equals to integration minus into infinity x into fx of x dx. So in case of discrete random variable, what is the formula I got? Sigma. So for continuous random variable, in place of sigma summation, I have to replace it by integration, because integration nothing but summation for continuous variables. So I replace sigma by integration. And here I'm having x into p of x equals to xi. So here x into here fx of x for discrete random variable. If x is discrete random variable, then what you get here? Fx of xi is nothing but p of x equals to xi only. Rs can represent by px of xi. It is a probability at the corresponding element only. The density function at a particular value is nothing but the probability at the corresponding element only. So therefore, this is a formula to calculate the expected value of a continuous random variable. So what is the formula? Integration minus into infinity x into fx of x dx. Similarly, if I want to calculate the expected value of a random variable y, then what is my formula? Y bar is equals to integration minus infinity. In place of x, I have to get y. So y into what is the density function of the random variable y? It is nothing but f y of y dy. So like that, I can write down the formula for expectation of any random variable. If it is continuous, I'll get the integration. If it is discrete, then I'll get the sigma. Then what is the formula for discrete random variable? xi into p of x equals to xi, or as this is also called as the density function at that particular element xi only. So this is the formula to calculate the expectation of a discrete random variable, and this is a formula to calculate the expected value of a continuous random variable. Let us see an example on a continuous random variable. Now, what is the example here? If x is a random variable with fx of x is equals to 2x. For 0 less than equals to x less than equals to 1 and equals to 0 otherwise, find E of x. So what they have given that? They have given the density function fx of x. So what is fx of x here? They are given 2x. So 2x when for what values of x? When x is 0 to 1. Then here what type of random variable here? X is in between 0 to 1 you may have infinite values. Therefore it is uncountable and infinite. Therefore it is called as what? A continuous random variable. For a continuous random variable, what is the formula to calculate the expected value? X bar is equals to integration minus infinity to infinity x into fx of x dx. So that equals to integration. Here in general the x value is from minus infinity to infinity. But here in the given problem the density function the x value is defined from 0 to 1 only. For other values of x it is 0. Therefore when x is 0 to 1, what is my fx of x here? 2x. So here have it here x into. So x into 2x dx that equals to 2 is constant 0 to 1 integration 0 to 1 x square dx. So integration of x power n is equals to x power n plus 1 by n plus 1. And similarly, the integration of x square is, so 2 into, in place of n, here I am having 2. So x cube by 3. And what are the limits here? 0 to 1. So that equals to 2 into, first you substitute the upper limit, then 1 by 3 minus, in place of x I have to substitute the 1. So 1 cube by 3, nothing but what? 1 by 3. Minus, what is the lower limit? 0. So 0 cube by 3 that equals to 2 by 3. So this is a expected value of this random variable x. And what type of random variable here? In this example you have taken as continuous random variable. Next we will see the expected value of a function of the random variable. Till now we have seen the expected value of a random variable for continuous as well as a discrete type. Now we are seeing the expected value of a function of the random variable. For example, g of x. What is here g of x? It is a function of the random variable x. So for example, I am taking, if x is a random variable, then what is g of x? It is a function of this random variable x. For example, I am multiplying the random variable x with 2 and then I am adding here 3. So I am doing some operation on the random variable x so that I am getting a new function g of x. What is g of x here? So g of x here, it is a function or it is a variable of what? The random variable x. It is a function of what? The random variable x. Now, if I want to calculate the expected value of a function of the random variable, then what is the formula? If x is continuous random variable, then what is the formula? Integration minus infinity g of x. So expectation of any function is that function you have to write down here. So here you write down small x actually. So g of x into fx of x dx. So what is the formula here? Integration minus infinity g of x into fx of x dx. What is g of x? It is a function of the random variable x, and here fx of x is a density function of the random variable x. Now, if x is a discrete random variable, then what is the expectation of the function of the random variable? So, e of g of x is equals to, in place of integration, I will get the summation sigma I g of xi into px of xi, or else I can write down this as sigma I g of xi into fx of xi, because fx of xi, the density function at xi, gives the probability at x equals to xi only. So these are the formulas for the expected value or the average value of a function of random variable x. So it can be also be represented by g of x bar. So already we have seen the notation of the expectation of a random variable. So u of is expectation of n. Any function can be represented by what? By bar also. And similar here also, g of x bar. So like that, you can calculate the expected value of a function of a random variable also. So in case of continuous random variable, this formula you have to use. In case of discrete random variable, so it is the formula you have to use to find out the expectation. For continuous, you'll get the integration. For discrete, you'll get the sigma. Let us see an example. So in an experiment, the input x and output y are given by the relation. So g of x is equals to x cube by 2. Here what is my y is equals to x cube by 2. Here x is the input and y is the output. If x is a random variable with the probability density function, fx of x is equals to 1 by 4 when x is 2 to 6 and equals to 0 otherwise, then find the expected value of y. So which formula you have to use? So what is my y is nothing but what? G of x. So it is a function of the random variable x because x is a random variable here. And how I get g of x? By taking the cube root and then by taking the cube and then divide by 3. I am getting the function g of x. Okay, so therefore g of x is a function of what? The random variable x. It means you have to use the formula of E of g of x. After that, you have to see whether it is continuous random variable or discrete random variable. Now, for that, you have to see the density function and you have to see the range of x. What is the range of x here? They are given x is from 2 to 6. So, between 2 and 6, how many values are going to get? You may get infinite values. 2.1, 2.2, 2.22, 2.2, like that. You'll have infinite values between 2 to 6. Therefore, the type of random variable here x is a continuous random variable. If x is a continuous random variable and if you want to calculate the expected value of a function of random variable, then what is the formula you have to use? Integration minus infinity. So expectation of any function is that function. It means g of x into fx of x dx. Now, in the given problem, the density function has been defined only from 2 to 6. When x is only 2 to 6, it has been defined. For other values of x, nothing but when x is minus infinity to and when x is 6 to infinity, it is 0. Therefore, I can replace the limits by 2 to 6. So, 2 to 6, when x is 2 to 6, what is the density function? 1 by 4. And what is my g of x here? X cube by 3 into dx. So that equals to 1 by, so 4 into 3, nothing but 12. You can bring it outside. So integration 2 to 6 x cube dx. So that equals to 1 by 12. Integration of x power n is x power n plus 1 by n plus 1. And similarly, you can write down the integration of x cube is x power 4. 3 plus 1, nothing but x power 4 by 4. And the limits are 2 to 6. So that equals to 1 by 12. Substitute the upper limit. So in place of x, how to substitute? So 6 power 4 by 4 minus the lower limit is 2. So 2 power 4 by 4. If I simplify, I'll get the answer is 40. So this is the expectation of the function x cube by 2, where the density function f of x is 1 by 4 and x is defined from 2 to 6. So like that, you can calculate the expected value of a function of a random variable x. In the similar manner, you can calculate the expectation of a function of a discrete random variable x also. So next we are going for conditional expected value. Already in the previous lecture, we have seen the conditional density function and conditional distribution function. We have seen the definitions and now we are applying the conditional density function to calculate the conditional expected value also. Now, what is a conditional expectation of a random variable x? And what is the given condition? The condition nothing but b. Then what is u of x by b is equals to integration minus infinity x into fx of x by b dx. So already we have seen the expected value of a random variable x. If x is continuous, then what is the formula? Integration minus infinity x into fx of x dx. Now what I want to calculate? I want to calculate the conditional expectation. So what is conditional expectation? What is the conditional probability? P of A by B is called as what? The conditional probability. How it is defined? P of A intersection B by P of B. The probability of the event A and given the event B has been occurred. So it is called as what? The conditional probability. So the probability, you are calculating the probability of the event A depending upon the condition of the event B. It is nothing but the conditional probability. The same thing you are applying to the density function and expectation also. So what is the conditional expectation? So when I give the condition, here it is called as a conditional probability. The same thing here for x, if I give the condition, then it is called as what? Conditional expectation. Now, what is the condition going to here? The condition given is b. Then integration minus into infinity x into x into. For u of x, you have to write down the density function fx of x. But for conditional expectation, we have to write down the conditional density function. So this is called as conditional density function. So this is called as the conditional density function. So what is u of x by b is equals to integration minus from infinity x into fx of x by b dx, where this fx of x by b is called as the conditional density function. So already we have seen the previous lecture. Depending upon the conditioning event, how we are defined, we have written the conditional density function. For example, if my conditioning event b is equals to x is less than or equals to b. Here b is a real number. Here b is a constant which is a real number. If I define the conditioning event like this, then what is the conditional density function? We have seen in the previous lecture, fx of x by b. So this is called as what? Fx of x by b. So this is called as fx of x by, this is nothing but b. The conditional density function is equals to what? Fx of x by integration minus into b fx of x dx. So the denominator is also called as fx of b also. For what values of x? When x is less than b. When x is less than equals to b, the conditional density function is equals to 0. Only when x is less than b, this is a formula for conditional density function. When x is greater than equals to b, the conditional density function is equals to 0. For what type of event? The event is x is less than equals to b. Then what is the conditional expected value formula? Previously I have seen integration minus infinity x into the conditional density function fx of x by b. So in place of fx of x by b, so replace this fx of x by b by this formula. Then what can I write here? So here what is u of x by b is equals to integration minus infinity x into fx of, for conditional expectation, here get the conditional density function. Don't write here x by b dx by b dy. Okay. So what you are writing here, write down the only the conditional density function in case of the conditional expectation. Okay. Now what is my event b here? My event b is nothing but x is less than equals to b. So this is the event b. Then integration minus infinity to infinity x into. So for this x is less than equals to b event, so what is here the conditional density function value? Fx of x by fx of b. Where what is the distribution function fx of b? Nothing but integration minus infinity to b fx of x dx. So it is a constant, but the denominator is always, here it is a constant. Okay. So previously I have defined from minus infinity to b. So x is less than b, how can I define? So minus infinity to b. I am writing minus into infinity as minus infinity to b and b to infinity. So when x is minus infinity to b, this is a conditional density function. When x is b to infinity, this is 0. That's why I have replaced the limits minus infinity to infinity by minus infinity to b. So x into fx of x by b. What is my fx of x by b here? Fx of x by, what is denominator? Integration minus infinity to b fx of x dx into here what I have here dx. Okay, so that equals to, so this the denominator is a constant value. It is not depending upon x, so you can bring it outside. Then you can write this as 1 by integration minus infinity to b fx of x dx. And what is the numerator here? Integration minus infinity to b x into fx of x dx. So like that, we can write down the conditional expectation also. This is for which event x is less than or equals to b. Similarly, you can find out the conditional expectation if the condition is x is less than or equals to b, or if the condition is some a to b, like that. So you can define the conditional expectation for this type of events also. Only the density function will change here. Now let us see an example problem. So if x is a random variable with PDF means probability density function. If x is a random variable with probability density function fx of x is equals to 1 by 40 for what values of x when x is 10 to 50 and that equals to 0 otherwise. So what I have to calculate here? Find the conditional expectation for the event a is equals to x is less than or equals to 40. So here in place of a I can take b also because the formula I have taken b. So what is my a or b is equals to x is less than or equals to 40. What I have to calculate? I have to calculate the conditional expectation of the random variable x, e of x by b. Nothing but e of what is here b is nothing but x is less than or equals to 40. So that I have to calculate now. So what is the formula? Just now here see the formula for the conditional expectation of the random variable x, here capital X. So e of x by what is the condition? If the condition is x is less than or equals to b, then this formula you have to use. So integration minus infinity to b x into fx of x dx by integration minus infinity to b fx of x dx. If you observe the numerator it is x into fx of x dx, the denominator only fx of x dx only. So it is a constant value. Okay. Now this is a formula for e of x by, so what is my b here? X is less than or equals to b. In the problem, if I compare what is my b value here? 40. Then what can I write here? Integration minus infinity to 40. So minus infinity to 40 x into fx of x dx by integration minus infinity to 40 fx of x dx. But what is the density function they are given? The density function they are given is 1 by 40. What is the value here? 1 by 40. For what values of x? When x is 10 to 50. When x is less than 10, it is 0. Nothing but when x is minus infinity to 10, it is 0. When x is 50 to infinity is 0. So how to take the lower limit? Because from minus infinity to 10, it is 0. The density function is 0. So what did I write down here? It equals to integration 10 to 40. Because my density function has been defined from only 10 to 50. So 10 to 40. The 40 is in the limits of this range 10 to 50 only. That's why I can write down here. The density function value is equals to 1 by 40. So x into 1 by 40 into dx by what is denominator here? Integration minus infinity, because from minus infinity to 10 it is 0. So I have to replace this minus limit by 10. So integration 10 to the upper limit here it is 40. So the density function in this range is 1 by 40. When x is 10 to 40, what is the density function? 1 by 40. If I simplify this, then 1 by 40 integration 10 to 40 x into dx by 1 by 40 here it is constant. So integration 10 to 40 1 into dx. So 1 by 40 will get cancelled. So integration of x is x square by 2 and the limits are 10 to 40 and integration of 1 is x with respect to x I am doing. That's why here it is x. So 10 to 40. Then so 40 square by 2 minus substitute the upper and lower limits. So 10 square by 2 by 40 minus 10. So if I simplify this, I am going to get the answer is 25. So like that, I can calculate the conditional expected of a random variable x. Let us see the properties of expectation. The first property is expectation of a constant is equal to the constant itself. That is, for example, c is any constant, then e of c is equals to what? C. What does it mean? Here expectation nothing but what? The average or the mean. What is the average value of a constant? For example, if I am having a value x equals to 40, 40, 40, 40 like that. Then what is the average value here? So for number of elements, so 40 plus 40 plus 40 by, okay. How many elements you have here? 4. So here all are constant values only. Okay. Then what I'm going to here? So 8, 12, 160 by 4. Nothing but what? 40 only. What does it mean? Here the variable, I'm taking a x is here, not a random variable. Here x is a variable. But this variable is consists of all constant values. All are having the same values. It means it is a constant value. My x is having only one value, then nothing but a constant value. Then what is the mean of any constant value? The constant itself. The same thing you have to prove. The same thing it can be applied for random variable also. So we know that what is u of x formula. If I take x is continuous random variable, then the formula is integration minus 1 to infinity x into fx of x dx. But what I have to calculate? I have to calculate expectation of the constant c. Then what can I write here? Integration minus infinity c into fx of x dx. So this is a proof of this property. Then here c is a constant. So I can bring it outside. So integration minus 1 to infinity fx of x into dx. Now what do you call this as? Integration minus 1 to infinity fx of x dx. This is nothing but the area under the density function fx of x. So what is the area under the density function? Fx of x is equals to 1. Therefore, from the properties of density function, already we have finished. So it's c into 1 and nothing but what? C. Therefore, what is the expectation of the constant is equals to the constant itself. And the second property goes to the expectation of a constant times the random variable is equal to the constant times the expectation of the random variable. So what they have given here, expectation of constant times the random variable is equals to constant times the expectation of the random variable x. That is nothing but u of cx is equals to c into u of x. So let us prove this property. So we know that what is the formula for u of x? If x is a continuous random variable. If you can prove this property by taking either continuous or discrete. I am taking a continuous random variable and I am proving the property. So for continuous random variable, what is u of x? Integration minus 1 to infinity x into fx of x dx. But what I have to calculate? I have to calculate u of the expectation of cx. So in the place of x, here I am having cx. So c into x. So this comes under expectation of a constant, expectation of a function of the random variable. So don't replace your x by cx. Here I write only the density function of the random variable only. So what is the density function of the random variable x here? Fx of x dx. Okay. C is a constant. I can bring it outside. So c into integration minus infinity. So x into fx of x dx. That equals to c into. So what is integration minus infinity x into fx of x dx? That is nothing but u of x. That is nothing but what? E of x. That equals to c into e of x. This is a RHS. What is u of x? From this I can write it down. Okay. Therefore, the expectation of constant times the random variable x is equal to constant times the expectation of x. So this is a second property of the expectation. Coming to the third property, if a and b are the constants, then e of ax plus b is equals to a into u of x plus b. Then how can I prove this? So what I have to write? I have to calculate the expectation of ax plus b. I have to calculate the expectation of ax plus b. So expectation of any function is that function, because what is u of g of x is equals to integration minus infinity g of x into fx of x dx. So in place of g of x, here I am having ax plus b. Then I can write here ax plus b into fx, the density function fx of x dx. So fx of x dx that equals to, I can write down this function as integration minus infinity ax fx of x dx plus integration minus infinity b into fx of x dx. So b into fx of x dx. A is constant, bring it outside. So integration minus infinity x into fx of x dx. Here b is constant, you can bring it outside. So plus b into integration minus infinity fx of x dx. Then equals to a into. So what is integration minus infinity x into fx of x? This is nothing but the expected value of the random variable x. So expectation of any function, that function. In place of g of x, here I am having x. That is nothing but what? E of x plus b into. So this is nothing but what? The area under the probability density function. What this value is equals to 1. So b into 1. That equals to what? A into u of x plus b. Nothing but. So this is a RHS. Therefore, the expectation of the function ax plus b is equals to what? A into u of x plus b. So this is your third property. Coming to the fourth property, expectation of the sum of the random variables is equal to the sum of the expectations of the individual random variables. That is, e of x1 plus x2 is equals to what? E of x1 plus e of x2. So how do you prove this property? So what is the formula? Expectation of the function of the random variable is equals to integration minus infinity g of x into fx of x dx. So similarly, how to calculate expectation of x1 plus x2 is equals to what? Integration minus infinity x1 plus x2. Here what is x1? It is a function of x. And what is x2? It is also a function of the random variable x. Okay, RS can represent by g of x1 and g of x2 also. So into what? Fx of x dx. That equals to integration minus infinity x1 into fx of x dx plus integration minus limit to infinity x2 into fx of x dx. So it's nothing but in place of g of x they are having here x1, that is nothing but e of x1 plus in place of g of x I am having x2. So e of x2, it is nothing but what? RHS. Therefore, the expectation of sum of the random variables is equal to what? The sum of these expectations. So these are the properties of the expectation. So in today's lecture, we have seen the definition of expectation. After that, we have seen the formula to calculate the expectation for a continuous random variable, discrete random variable, and then the expectation of a function of random variable. After that, we extend this concept to conditional expected value, and then we have seen the properties of the expectation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.